In March 2025, a metallic sphere discovered in Buga, Colombia sparked a rush of scientific investigation. When Russian physicists suggested it could be a time capsule containing encoded physics, their communications abruptly ceased. Did the artifact contain knowledge intended to teach, rather than simply be studied? What kind of information could silence the world's leading scientists, and what does this imply about its origin? The answers could fundamentally reshape our understanding of physical laws. A teaching-oriented technology does not rely on written language or instructions. Instead, its lessons are embedded in its behavior, revealing truths only to those capable of observing, measuring, and interpreting them, a core principle of the time capsule hypothesis. The Bugosphere is not a vault of documents, but a tool whose operations convey the message. The concept has precedent. Imagine giving a modern transistor to a Renaissance scientist without manuals. The device itself would be a puzzle. Its materials, function, and effects would point to scientific principles far beyond contemporary knowledge. Observers would need to invent new branches of physics to fully explain its capabilities. The Bugosphere functions similarly, inviting reverse engineering. Its behaviors, mass shifts, continuous cooling, and apparent inertial shielding, defy conventional explanation. The sphere provides no markings or guides. Its knowledge is demonstrated through its own actions. If the time capsule theory is correct, its creators anticipated that scientists would not just analyze the artifact, they would learn by probing and reconstructing the principles underlying its behavior. The sphere functions as both teacher and lesson, bypassing the limitations of language, culture, and even time. Any observer, whether individual or civilization, must learn by experimentation. The more sophisticated the observer, the deeper the insights they can achieve. In this sense, the sphere serves as a universal interactive textbook. If the sphere truly encodes knowledge, its purpose is not to explain directly but to provoke discovery. Each anomaly offers a clue, pushing researchers to rethink physics. The artifact embodies knowledge in its very construction. Its flawless metallic shell, 50 centimeters in diameter, primarily high-purity aluminum, and with a Brinell hardness exceeding 300, is unlike any known manufactured object. No welds, seams, or access points are visible, and industrial processes cannot replicate such a seamless structure at this scale. Inside, advanced scans reveal concentric shells, a central chip-like core, a network of fiber optic filaments, and up to 18 microspheres precisely arranged. This complex internal structure, layered throughout the volume, exceeds the capabilities of any known additive manufacturing or industrial technique. Laboratory-scale photonic metamaterials exist, but never in a solid, seamless metallic sphere at this size. Experts such as Dr. Jan Meyer and Dr. Lauren Soloff confirm that such hardness and integrated complexity are unattainable with current technology. Two extraordinary possibilities remain. Either the Bugosphere is a secret human technological leap with no precedent, or it is the creation of a builder with knowledge and methods beyond current human capabilities. The manufacturing itself is a clue, challenging assumptions about feasibility and origin. Negative mass, a concept in theoretical physics, behaves contrary to everyday experience. Unlike normal matter, which resists acceleration, negative mass would accelerate opposite the applied force. While laboratory analogs exist in ultra-cold atomic systems, true negative mass remains theoretical. In a system combining positive and negative mass, the two would continuously chase one another, generating thrust without expelling mass, reactionless propulsion. Reported behaviors of the Bugosphere, motion without visible exhaust, apparent mass changes, align with predictions of negative mass systems. If confirmed, this would mark the first real-world demonstration, enabling spacecraft and satellites that operate without conventional fuel and energy systems beyond current limitations. Agencies such as DARPA and NASA have actively funded research into exotic propulsion, quantum metamaterials, and inertial mass manipulation, aiming to develop technologies that could bypass conventional constraints. Congressional hearings on unidentified aerial phenomena and budget allocations reflect a strategic urgency. Mastering these effects could redefine aerospace defense and energy. Russian institutions have similarly invested in metamaterials and quantum systems, viewing the Bugosphere as more than an academic curiosity. Replicating or explaining its effects could confer a decisive technological advantage. Secrecy is enforced strategically rather than out of paranoia. The sudden silence from Russian scientists fits a recognizable pattern in advanced technology programs. reflecting the high stakes and global competition surrounding breakthrough propulsion and physics research. When theoretical implications begin to approach practical applications, discussions move behind closed doors. In cutting-edge physics, the line between open science and national security is thin, and the urgency to gain any technological advantage is palpable. On July 18, 2025, physicist Patrick Morsillo published a paper that stunned the scientific community. The study detailed a series of measurements on the Bugosphere which, if accurate, challenged the boundaries of established physics. Morsillo's team reported that the sphere's mass, measured with high-precision digital gravimeters and calibrated reference objects, increased by 8.1 kilograms over 36 hours, with no material added. There were no observable changes in size, composition, or external features. Measurements were carefully time-stamped, witnessed by multiple researchers, and compared against control spheres of identical composition. Instrument calibration logs were included. Thermal data revealed another anomaly. Using high-resolution FLIR cameras and contact thermocouples, the sphere consistently absorbed 100 watts of heat from its environment without any detectable power source, fuel, or refrigerant. Control objects in the same conditions exhibited no such effect. Data logs confirmed a stable temperature gradient, validated by redundant sensors and multiple trials. Propulsion measurements were even more confounding. On a sealed inertial reference platform equipped with microaccelerometers and laser gyros, the sphere exhibited motion without ejecting any mass. According to Morsillo, neither vibration, airflow, nor electromagnetic interference could account for the observed movements. Drop tests and platform oscillations indicated the sphere's inertial response was reduced by up to 81% relative to its measured mass, an inertial shielding effect with no theoretical basis in conventional physics. The phenomenon varied with orientation and appeared intrinsic to the sphere's structure. Morsillo's paper included thorough documentation of experimental protocols, environmental controls, anti-static measures, and chain-of-custody procedures. Raw data, mass logs, thermal curves, and inertial readings were provided as supplementary files. While independent replication has not yet occurred, the simultaneous occurrence of mass increase, continuous cooling, and inertial shielding is unprecedented, demanding careful attention. The challenge for the scientific community is clear: reproduce these effects or identify errors that might explain them. Verification requires multiple internationally recognized laboratories with the most advanced instruments, including gravimeters and comparators certified by national standards agencies such as NIST, PTB, or NPL. Every instrument specifications, calibration, and logs must be documented. Controls are essential, using dummy spheres identical in size and composition. Thermal measurements should be performed in precision calorimetry facilities with redundant sensors, high-resolution FLIR cameras, and stable environmental conditions. For inertial shielding and non-ejective propulsion, tests must be repeated under blinded, randomized conditions, with careful logging of all power inputs and outputs. Gravitational physics teams using torsion balances and high-resolution inertial measurement units are critical. No single lab's results are sufficient. Convergence across multiple sites is required to validate or refute the reported 81% shielding factor. Chain-of-custody protocols must be rigorously followed, with video documentation and tamper-evident seals. Data integrity relies on cryptographic hashes, redundant backups, and open access to raw data. Pre-registration of experiments with public analysis plans prevents selective reporting. Continuous monitoring of temperature, humidity, and electromagnetic conditions is mandatory. Only when multiple trials, at least 20 per lab, yield consistent results will the anomalies transition from unexplained observation to confirmed phenomena. Until replication occurs, the Bugosphere remains a profound scientific question. Morsillo's July 2025 publication documents an 8.1 kilograms mass increase, a persistent 100W endothermic effect, and non-ejective propulsion, phenomena beyond standard physics. Russian scientists initially collaborating with Morsillo ceased public communication, a familiar pattern in investigations involving potentially strategic technologies. To date, no independent laboratory has reproduced the findings, and the sphere's internal structure remains accessible only via advanced scanning. Official records confirm the artifact's existence, engineered internal features, and unusual materials, but its origin and full capabilities remain undisclosed. As it stands, the Bugosphere challenges current scientific understanding and international transparency, with its ultimate Impact dependent on future independent verification and open review.